The alternative form of derivative and differentiability. This video is about finding the derivative at x equals c using the alternative form of derivative, describing the x values at which f is differentiable. What is the alternative form of derivative of f at x equals c? The derivative of f at x equals c is given by this formula, f prime c equal to limit x approaches c, f of x minus f of c over x minus c, provided the limit exists. Example 1. Using the alternative form of derivative. Use the alternative form of derivative to find the derivative at x equal to c, where f of x is square root of x and c equal to 0. So let's start with f of x equal to square root of x. Substitute x, which is c, and c is 0. So we substitute x equal to 0. So this becomes f of 0 equal to square root of 0. And square root of 0 is 0. Now let's write the alternative form of derivative. So f prime c equal to limit x approaches c, f of x minus f of c over x minus c. Now substitute c equals to 0. The alternative form becomes f prime 0 equal to limit x approaches c 0, f of x minus f of 0 over x minus 0. Now we substitute f of x equal to square root of x and f of 0 equal to 0. So we have this limit x approaches 0, square root of x minus 0 over x. Let's simplify. Square root of x and the x can be written as square root of x times square root of x. So now we can cancel these two and you're left with limit x approaches 0, 1 over square root of x. Now if substitute x equals 0, so we have 1 over 0 square root. Now division by 0 is undefined, so therefore we'll say derivative does not exist. So the answer is D and E. Example 2. Use the alternative form of derivative to find the derivative at x equals c, where f of x is x squared plus 2x and c equals to negative 2. So let's start with f of x, and f of x equal to x squared plus 2x. Substitute x equal to what c is, and c is negative 2. So we substitute x equal to negative 2. So this becomes f of negative 2, square of negative 2 plus 2 times negative 2. The square root of negative 2 is 4. 2 times negative 2 is negative 4. Now 4 minus 4 is 0. Now write the alternative form of derivative. F prime c equal limit x approaches c, f of x minus f of c over x minus c. Now we substitute c equals to negative 2, and this alternative form becomes f prime of negative 2 equals limit x approaches negative 2, f of x minus f of negative 2 over x minus 2. Now we substitute f of x equal to x squared plus 2x and f of negative 2 equal to 0. So this becomes x squared plus 2x minus 0 over x plus 2. Factor and simplify. So if you factor, so factors are x times x plus 2. Now we can cancel out x plus 2's and you're left with limit x approaches negative 2 of x. Now we substitute x equal to negative 2. So the answer is negative 2. Differentiability of f of x. A function is not differentiable at x equal to c if f of x is not continuous at x equal to c. So just as shown in this graph, at c the function is not continuous. So the function is not differentiable at x equals c. But function is differentiable from minus infinity to c and from c to infinity. Function f of x is not differentiable at x equals c if f of x has a vertical tangent at x equals c, as shown in this picture. So, but f of x is differentiable over from c up to infinity. A function f of x is not differentiable at x equals c if f of x has a short term at x equals c. So here there's a short term too. So f of x is not differentiable at c. But f of x is differentiable from minus infinity to c and c to infinity. How to find the x value where f of x is differentiable? Since f of x is differentiable over its domain, just find the domain of the f of x. Example 3. Determining differentiability. Find the x values where f of x is differentiable. F of x is equal to square root of 2 minus x. So the graph of f of x equals to square root of 2 minus x is shown as the curve is going to the left and there's a vertical tangent at x equal to 2. So let's find the domain. The domain would be x less than or equal to 2. In interval form, minus infinity 2 including 2. But there is a vertical tangent at x equal to 2. So therefore f of x is not differentiable at x equal to 2, but differentiable on the rest of the domain. So therefore we'll say that f of x is differentiable over minus infinity to 2 excluding 2. Example 4. Determining the differentiability. Describe the x values at which f of x is differentiable. So here we have f of x equals to x plus 1 over x minus 1. First find the domain. So to find the domain of f of x, set the denominator to 0. X minus 1 equals 0. Now solve for x. X equals to 1. So this is the value where f of x is undefined. Therefore the domain is minus infinity to 1 or 1 to infinity. Since function is differentiable on its domain, therefore f of x is differentiable from minus infinity to 1 union or 1 to infinity.